Hello everyone, my name is Joe Scorsone, channel is called Scorsone Enterprises, and today we're going to be starting probably a little mini-series about a topic that I dove into probably about a week ago, and just found it really interesting, and it kind of shaped a way that I'm going to continue to think about things, because the way that it's structured my thoughts and the way that I can now explain things is just, it's fun. It's very enjoyable. So the topic that we're going to be talking about is delta neutral. And so we're going to talk about what that is a little bit. And then I'm going to code with you guys, I'm actually going to type it along with you guys, a simple delta neutral portfolio in QuantConnect. And we're going to backtest it and see how pretty much nothing happens to the portfolio. And that's exactly what we're looking for. So if you guys like videos like this, check out my Twitter as well. You're going to get all the updates on here too. We're so close to 1,000. Let's get there by the end of the year. And if you guys notice in this tweet as well, if you guys want access to the algos that I use to get these trades, these entries, I'm still in this one actually. And I did post this buy on my Twitter as well as soon as I did it. You guys can use code July30, well, JUL30 for 30% off of these algorithms that I made in collaboration with Flux Algo. You guys get 2 of them. You guys get, actually I can show you right here, bang, this is actually on Raytheon. You get these levels and this machine learning. They're both machine learning, but you get these predictions and these levels. So very useful stuff, especially if you like to actively trade. You could even trade it slowly. You don't have to always be day trading options. There's a lot of different ways to trade. But let's hop into what we're going to be coding today. So I have a little delta neutral file already made. I have a few bits of code already written, and we're going to implement some functions, all right? So, and I do just have a reference up here to make sure that I don't screw anything up. So how are we going to do this? So let's actually get out Microsoft's best invention ever. It's on this screen. Microsoft Paint. Here we are, fellas. All right. So what is, oh gosh. All right, I guess I can't full screen it. Whatever. So delta, that's a delta neutral. There's an R in there somewhere. Delta neutral. We're going to make a delta neutral portfolio. That's a symbol for a portfolio. From the value of our options, the delta of our options minus the delta of how much stock we own. Right? That's how it's done in the Black-Scholes-Merton equation, that partial differential. And that's what we're going to implement for an actual portfolio here. So the way that we pretty much need to do that is we need to get an option. We're just going to call it V, an option V. And we need to derive its delta. An option's delta is how much the premium of the option will change per dollar move in the underlying. So we need the options delta, and that'll range. We're going to use at the money options, so generally they're going to be around like 0.4 to 0.6. And we have to multiply that by 100, so between 40 and 60. Right, because it's an option. If you ever look at an option and it says it's $1, you have to pay $100 to actually get it in your account, because this represents like per single share, and obviously, I shouldn't say obviously, you just simply meant to know. Options are by the hundreds. So now we know what we're looking at from our option. We need to understand what our options delta is. That way we can hedge it properly. We then, the delta of our stock is 1 per share. That's an S. If you buy 1 share of any underlying, your delta in that position is 1. If you buy any quantity, X quantity of shares of any stock, your delta for that position is X, right? X amount of shares, your delta is X. That's how these things work. So what we want to do is make it so that way this V's delta, we're just going to call it V, V delta, I guess we'll write it like that, minus the delta of our stock position, we want to make that 0. We want to get that as close to 0 as we possibly can. We want to make that neutral, right? And now once you get this, once you organize your portfolio in a way where the price of the underlying and the way that the options premium changes with the underlying offset each other, then you get a lot of different opportunities and ways to model your portfolio with different aspects of financial markets, like volatility, for example. We're not going to get into that this video, but that will be, I'm going to do that because I think it's awesome. So that's pretty much what we're going to do. We're going to buy some options and we're going to hedge them with stock to get our overall delta of our portfolio to 0. That is our plan. So what are we doing here? We're getting some options. We're only going to do this on SPY. And as you can see here, I'm getting options that are 21 to 30 days out. And there's no good reason for that, chosen arbitrarily. A lot of this stuff is just chosen arbitrarily, just for the sake of this explanation being simple and quick. So this universe setting is for our option selection. This option universe, right? This is just so that way we can constantly keep on updating our contracts in our algorithm. So then we're just setting up some variables, right? We have the symbol of our underlying, the symbol of our options, and then we have some other things that we're going to need later. The quantity of how many option contracts we're buying, hard coded to 5, again simply for simplicity, and then contract symbols as a set, so that way later on we could quickly look up the Greeks of our option, the delta of it. And then we're going to rebalance our portfolio to make sure that we're staying delta neutral. We're going to do that every 60 minutes. Ideally, you'd be able to do it every minute, every 30 seconds, right? But I don't want to sit here for 4 hours while I watch a backtest finish, right? A little sneak peek, and we did pretty dang good. But so that's why we're using 60, just so that way it doesn't take too long. Next, I just have some boilerplate just to close options that are close to expiration. If they're going to expire in less than 5 days, then we're going to just liquidate them, just getting our option chain. And then we have 2 functions here that we're going to implement to get our portfolio delta and then to actually rebalance. So let's go through, and first let's get our option chain. We had the chain. First, let's get the calls in our algorithm, right? So we want a list of option contracts. So we're just going to say X for X in chain if X dot ID, is it ID? Yep, dot option right. What right do we have when we own this option? Is option right. That's one word. There we go. Option right dot call. So now we organized all the contracts in this chain. We only want the ones that have the option right as a call. All right. So now that we have these calls, we need to make sure that they actually exist, right? We got to do this kind of check, but only on the calls. So we're going to say if calls is none, then we're just going to return, because obviously then there'd be no contracts for us to even look at. Next, we want to get the spot price, which is the, what did I call it? Self.sim. Yep, just the price of that. So that way we can get the our actual call contract, the singular one, because we're going to say sorted. And then what do we want to do? We want to, actually, we don't want to sort it like that. We can just get the minimum. We can get the minimum of our calls. We're going to use X. Excuse me. We're going to say key is lambda X, and then we can say our absolute value of our X dot strike. And I'm going a little fast. I will explain this. I'm going to keep that lowercase. X dot strike minus our spot price. So now what is this doing? Key. This is 1E. What is this doing? We're going through our calls, subtracting the strike price from the spot price, right? And then we're getting the smallest deviation. So if we want to, if our spot price is 100 and we have 101, 102, 103, right? 101 minus 100 is 1, right? And then so forth. 3, the closest to the money is the minimum of this operation, right? So write that out in some more detail. We're doing 100. We're doing the strike price minus our current price. Whatever the smallest difference is, that's the closest to the money, is the operation that we're doing. Right. So now we also need to check if the call contract is none, because then we can't do anything. Right. Now we actually want to go through and see if we have options in our account. If we do have options, then if we're holding options, then we're good. Then we just have to keep on making sure that we can hedge against them properly. But if we don't, we want to get some so that way we can achieve some delta neutrality. So if len, nope, not that yet. We want to make a variable called options holdings. I don't know why that was so hard for me. So we're going to say x.key once more. Actually, I want a tuple. I want a tuple x.key, x.quantity for x in, for x in self.portfolio, because we can iterate through that because we're using QuantConnect, and QuantConnect is really well designed. So we're going to say to self.portfolio, and we're going to say if x.value, because x is a dictionary, we have the key and then the value, x.value invested, are we holding this symbol, and x.value .type, what kind of type is the security, equals security I don't know why I scrolled all the way down to it, if security type dot option. Right? So now, and I'm gonna bring that back here, cool. So now I have every single option I hold in my QuantConnect portfolio. Why are you squiggling? Key value pair has no attribute quantity. You should. For x, x.value.quantity. Sorry about that. Cool. So now we actually have these options, so we can check if the length of option holdings is 0, then we actually want to buy some. So we could then just, we're going to straight up going to mark it self.market order our call contract dot symbol and self.quantity amount, just to keep things simple. Next, I want to save the contract to look up Greeks later. I played guitar before, so my forearms are all tight now because I played technical death metal, and sometimes it just tightens up, you know. Wanted to play it before I went to the gym though. Felt like that made some sense. Okay, so I want to save this symbol for later. So now, total delta, we will make a new variable, and we are going to grab the Greeks of this call contract, Greeks.delta times 100 because it's options, and then times self.quantity holdings of them. And then we're going to log that total delta, there we go. Log that because logging stuff is good. So now we want to say target, I'm going to make a new variable, target stock quantity, how much stock do we have to own to offset this, is just an int version of negative total delta, because calls we're always going to have positive delta. Next we can market order, again just for simplicity, market order self.sim or actual spy.symbol, and then target stock quantity amount. So now we have our initial options purchases done. So now, actually, we have our initial hedging done, but we have to maintain that hedging, right? So that is what we're going to be doing when we get our portfolio delta. We're going to see how much we have to change our hedging by. So we want to do a similar thing up here. We want to get a chain in here. We can do that by calling self.currentSlice, and then we can get the proper chain. Next, we want to create a dictionary of our option contract that we're storing in here. We want to just save it as option contract in Greeks. Could we just do this from the start? Probably, but I think it makes a little bit more sense to just store the whole contracts. That way later on, if maybe I want to look at it's Vega, it's implied volatility, it's this, it's that, I now have the whole contract instead of just one Greek of it. I feel like I'd have to change it later on anyways. For this, It doesn't matter, but in general, I digress. Not that. I'm going to say contract dot symbol contract dot Greeks for contract in self dot contract symbols. Cool. And we have to wrap that in curly braces, not square brackets. There we go. Beautiful. Yeah, nailed it. So now that we have these Greeks, then we could loop through them in a nice way. We can say for symbol quantity. Well, actually, we're gonna make ourselves a new list first. So that way we can then just have everything that we need. We're gonna say for symbol quantity and security type in, and then we're gonna make ourselves a new list here. And we're gonna say x dot key, x dot value dot quantity, x dot value dot type. Remember how we did it up here. So now that we have this, we're going to say for a little bit of nesting. We're going to say for x in self dot portfolio. If x dot value invested and x dot value dot type in, we're going to check to see if it is a option or an equity. In security type dot option or security. Again, if I ever wanted to, why can I not security type? Mamma mia. Equity. Again, forward looking. You don't really have to do that part of it in case you ever want to have a different asset class in it. But loop through it like that. I don't need a comma here. Bang. Okay, cool. So now we're looping through everything that we have in our portfolio by its symbol, quantity, and security type if we're invested and it is a security, and if it's an option or an equity. Yes, you could do this on futures as well, but we're just doing this only on equities right now. So if we have a security type that is a option, we have to log the delta differently. So we're going to say Greeks is, and we can use our Greeks lookup that we made earlier. Okay, thank you, LSP. Greeks lookup, and then dot get, and we want the symbol that we're looping through or none. If Greeks is none, then we have nothing to do. Oh, sorry, if Greeks is not none for this point, if Greeks is not none, then delta plus equals Greeks dot delta times the quantity that we hold times 100. And then we're just gonna have a simple log, self.log. No Greeks available for that specific symbol. We're just not gonna handle that delta then. Else we can just say delta plus equals quantity because that means that it is a equity. And then we can just return our delta. So now we're looping through our entire portfolio and we're getting the correct delta. I don't like having that there like that, or do I? I do. I do enjoy. A little bit of a syntax war in my head right now. I do like that. So now that we have the delta of our portfolio, we need to define a simple delta tolerance to stay under. I'm going to say delta tol to be consistent with my reference in case I have to copy and paste. I doubt I will, but forward looking. So if the absolute value of our delta is greater than our delta tolerance, then we have too much delta. So we're going to say our current stock quantity is portfolio And then we need the self.symbol because it's the only thing we have. Quantity. And then we need to have a target stock quantity that we want to achieve, right? What is our target stock quantity? Is the integer version of the current stock quantity minus our delta. From that, we can self.market order, I have a self.symbol, and then our target quantity minus our current quantity. That is the difference that we have to make up. And then we can just, why are you complaining? Current slice is not defined. Yep, because I want this variable instead. There we go. And that's it. That's all that we need to do. So if we then check here, because remember we're calling rebalance. We're calling rebalance whenever we each liquidate an option and just every hour. So now we get a result like this. We can see that we're always short and we're always long an option, which is exactly what we want to see. We pretty much have no return. Even if we were to scale this up and actually short as much stock as we could, so about 5x, we would still have very low return, which is exactly what we want. Do have a high win rate, which is neat, I guess. And if we go through our logs here, we can see total portfolio delta initially is that, and then we're going through and we have our portfolio delta changing, and then we are just rebalancing it. We can see here that it's already fine, it's within the bounds, but whenever we need to rebalance, we just bring it right back down by scaling how much SPY we own, right? Because see here, every hour, we're buying calls, shorting against it, shorting more, covering a little bit, bringing ourselves as close to neutral as we possibly can. That is the name of the game for a delta neutral strategy in QuantConnect. The next things I want to do on this channel is take this another step forward and be net long volatility from a delta neutral perspective. So that way we're kind of turning off the price of the underlying security affecting how our trade is going and trying to only be long volatility. Next, well, not next, and what I want to do on this channel is some more stuff with Zig, because I made that actor model and I want to do something with it. If you guys have used my actor model and made a project with it that you guys like a lot, you liked how I made my actor model, then comment your GitHub repo in the description. I do have to make an update to the actor model too, because I made a change to it locally in one project that I don't know if I'll ever make a video on, because it's like almost 3,000 lines and I don't even really use it. It was kind of just like I had nothing better to do. I really didn't, so I made that project. I might go through it and just talk about it because it is pretty damn cool. I made a post about it in the Zig community on Twitter, but whatever, I digress. Yeah, if you guys enjoyed this video, comment other videos that you want to see. You guys are happy that Ellie hung out with us the whole time too. Is she sleeping? I don't know. She knocks out when I play guitar too. But yeah, please comment what else you guys would like to see from me. Please comment language suggestions, video suggestions, your own projects that you used with any of my SIG libraries. I would love to see that. And yeah, make sure that you guys take advantage of the July 30th or the July coupon code to get 30% off my indicators of Lux Algo. So yeah, you guys all have a great, great week. If I don't upload before the 4th of July, happy Independence Day. I will see you guys in the next one. Ciao, ciao.